Been some slight technical difficulties, but I'm sure it's going to be all right. So, hi and welcome to my talk, The Engineering Challenges of Wanderer, a VR title for Unreal. My name is Sebastian Tengdahl. I'm a lead engineer at Mighty Ice. If you're wondering where this accent is from, I'm originally from Sweden. I've been here for almost 6 years now, 3 of which I spent working on Wanderer. A bit of background for this talk. I wanted to talk about the game that I've been working on for almost 3 years now, and what stuck in my head was, instead of some big grandiose topics, it was more of the minor issues that made up the journey of making the game. And I thought, great, I can talk about that for way too long. It's a bit weird, but I'll submit it and see what happens. And here we are at GDC in the big room, first talk. So, Wonder, the game we made, what is it? Well, to keep it brief, it's a VR puzzle adventure game with major emphasis on time travel. You travel from time period to time period, bringing items across and solving puzzles to progress the plot. Not sure if this video is playing either, but this one was just playing and showing the game. So things we really wanted to focus on when making the game was having a physical presence. So wanted our hands to actually push and pull objects. We found that just having them phase through objects can be pretty immersion breaking, so that was a big one for us. We wanted to make the travel from level to level seamless, or at least seem seamless. Having the game freeze or bringing up a loading screen in the player's face can likewise be pretty immersion breaking. We wanted to have a lot of object interaction. Anything that looks grabbable should be grabbable. And we wanted item persistence. After you grab those items and move them across time and space, we wanted them to stay there, no matter if you move them a few centimeters or a few centuries. All of these came with its own set of niche issues, some of which I'll cover today. Starting with one of the bigger issues we had with introducing physics interaction as a big part of the game. So our game has a lot of interaction, like you can see. We made a script that spawned every single grabbable item in the game. We have physics objects, constrained doors and drawers, and animating skeletal meshes that's used for puzzles, as well as 2 really complex objects that you're always carrying with you with the in-game hands. Not only that, but to avoid the really strange issue of not knowing where your in-game hands are, because, well, your motion controller is on one side of the wall, but your physics representation of the hand is inexplicitly on the other side of the wall. We made a system to make the hands go into an overlap state and show through walls if they move too far from the motion controller, or you teleported too close to a wall, or you did anything. Also, this system carries over to any attached object, any grabbed objects, anything attached to what you're grabbing, and so on. This might not sound so bad, but to detect that if something is no longer overlapping, everything needs to generate overlap events, and having moving objects generate overlap events in Unreal can get expensive. You can see here a frame dump from when our game was in pretty bad state. 1/3 of the entire frame is just going to updating overlap events. It doesn't help that skeletal meshes that's animating also counts as moving, and if a skeletal mesh has an animation blueprint, they're always moving, even if they're completely still. There are ways to mitigate this, like using update rate optimization or turning on and off and no skeletal update dynamically, but we found that this wasn't enough. So what did we do to solve it? Well, we didn't really, but we worked around it. We realized that we don't need high precision overlap. It's fine if it's a frame or two late. So we made a system. We made an amortized update overlap system. Takes all the overlaps that's slated to happen for a frame, adds them to a big list that's unique per component, and at the end of the frame, we update all of them based on a priority. We do this for however long we allow it for. In our case, just 1 millisecond. And then all the remaining ones update their priority and are left for the next frame. This system worked great for reducing the overlap time without actually reducing the amount of overlaps that we had, and without any real noticeable impact on gameplay, except for one case, which I'll get to. So there's two cases where the system doesn't really work, one of which is only really theoretical, because sometimes Unrail can call the overlap function with a bunch of extra parameters for really complex overlaps. We didn't really find that this was an issue, so in those cases we just fell back on Unrail's normal system, but it's worth mentioning. The other case where it didn't really work was in our drumming minigame. So we have a drumming minigame. You don't need to know much about it other than you swing a drumstick at high speeds, as you tend to do when drumming. And because the overlaps can be 1 or 2 frames late, that meant that the stick could just go straight through the drum. And for a rhythm game, that's terrible. But it was pretty easily fixed by adding a Boolean for objects to opt out of the amortized update overlap system. So yeah, this system worked great for offloading a lot of the burden of having a physics-heavy game with a lot of overlaps. So the videos wasn't really working here, so might need to go to, yeah. God, the audio is awful. So next is level streaming, or to be more precise, level streaming when you go completely against how Unrail is meant to do it. So a little background on this one as well. Time travel in Wanderer is done seamlessly by placing an item from the time period in your watch, which then loads the level, fades to white, move the player, run all the begin play stuff, and then fade away from white. We do a few tricks to make the almost 1 second hitch when that happens not noticeable. The main one was changing the redraw color in Unrail to be white rather than black. So even if the screen is completely frozen, if you move your head, you're not going to notice it. So this system is done using level streaming. So if you go to the video, that's what's actually happening under the screen. Or under the hood. Again, the audio there is awful. Level streaming is a system to have a most level stream in and out predefined sublevels based on need. So what we actually did was just hide the previous level, move the player, and then show the new one, or new ones. And this method we used opposed to the more traditional method of just loading the level and then opening it for 2 major reasons. One was to have not have to, well, so the normal method recreates everything, so you would have to deserialize the player, the hands, whatever they're grabbing, their inventory, all our manager, and whatever else. And it would be really hard to make this not noticeable to the player. Also, with the level streaming method, we can dynamically choose what levels to load. If you've already progressed halfway through a level, then you don't really need to load the first few sub-levels of that level. But this method of doing things comes with one big and one small problem. The small issue is that our master level is massive. It contains 130 sublevels, so loading that when developing is a pain. And it becomes even worse if someone left a few levels visible in the last commit. This one's not too major, might sound like it is, but we could just work off of the sublevels, and then we made it so that if you play from the menu, it only loads the levels that's actually needed, so it doesn't load the entire master level. The major issue, however, is we're making a pretty large VR game, so kind of needs it to have baked lighting, and, well, with level streaming, that kind of broke. Trying to build the lighting from this huge master level would most of the time just crash, and it also wasn't really feasible to automate, because, well, swapping the levels. And because building lighting could sometimes take up to like 8 hours, it's really something you wanted to do overnight. So what we did instead was to put all of our sub-levels into one level that we could then build the lighting from and then just put into the master level. This seemed to work fine until we started seeing strange lighting issues. Like you can see the curtain is just unlit, and the cupboard and the fan. We were already pretty far into development, so instead of redesigning several systems that we really didn't have time for, we decided to look at how level streaming is done and see if we could fix or at least mitigate the issue. What we found after a lot of UDN searching, looking at very abstract code and quite a bit of help from Alex Stevens from Epic, was that lighting data is split into two parts. One for the level the lighting was built from, which I'll call the root level, and one part for all the sublevels. To simplify it a bit, the lighting data from the sublevels slot into the lighting data of the root level. The problem we had was because if the sublevel is shown before the root level, they would slot into whatever data was there previously. And then when you show the new one, it would just overwrite it. So those sublevels lighting data just wouldn't be there, and it would fall back onto the root levels lighting data, which is not as precise. You could get around this by showing the levels in a very specific order, namely the lighting level first, then the root level, and then all the sublevels. But if you ever want to swap lighting scenario, what you would have to, which we did, you would have to hide all the levels and then show them in that specific order again. All the begin plays would happen again, and it would just be pain to manage. But now that we knew what the issue was, we knew how to fix it. After all that, there really wasn't much to it. When a root level is turned visible for the first time, we update the lighting data of all the other visible levels, which guarantees that the correct lighting data is put into the root level. This lets us keep our current streaming method and have our level transition to stay seamless. Easy. And it took a few weeks and hiring someone dedicated as an engine programmer to solve that one. Okay, moving on to moving away from low-level engine changes to more simple game systems, specifically our grabbing system. Like I said earlier, we wanted to make it so that everything that looks grabbable is grabbable. There were many problem areas with making this, when grabbing things in VR, especially after adding physics, as you can see. But before any of that, we had to actually move the object to the hand and grab it at the right location relative to the object. We tried a few ways of doing this, but eventually we settled on having a data table consisting of all the post names and then the bone rotations for each finger. Objects themselves would have a saved post name referencing this list, as well as relative transform, a bone if it's applicable, and spline data, which I'll get back to in a bit. The problem with this one was that it was incredibly painful and tedious task to make poses. You would have to spawn a preview hand, reference the actor, move the hand there, pose it, and then hit an in-editor button. And doing that multiple times for each hand. And imagine doing that for almost 400 objects, and you might see why there's an issue. We did a few things to make this process less of a living hell. We made a utility widget to help the creation process. We're using a hand and some 3D widgets with IK. We made it easy to select, edit, and save poses. This was pre-control rig, so it's a bit rough, but it got the job done. Added a few helper functions as well. Pretty much every pose you would want to duplicate, swap hand, mirror. So functions like this helped a lot. We also added a spline system, so instead of making 10 poses for a round object or a book like this, you could just make one. And for like a baseball bat, you would want like several poses around it. This could also fix that. The code for this was quite a challenge to get right, with the transform math, having it saving and recreating the spline on the fly, projecting it onto the hand, but then the result made the pose creation way less of a drag. One place that our system struggles a bit is for creating sub-poses. Things like firing a gun, it was really hard to make it so that the pose would blend nicely with the front pose and the to pose and the trigger of the gun. You could probably solve this by using a curve, but we didn't because time constraints. Also, this method of doing things creates a really ugly adding graph, so if you want to do something similar, be warned. But yeah, making it easy to create a lot of poses played a big part in making grabbing feel more like it's actually the player grabbing things rather than their in-game character. So after the player has grabbed all of these objects and scattered them across time and space, we want to actually have the items stay there following a set of rules. The big issue here was between UX, design around warping, and what makes sense with time travel. I think the system got redesigned like 5 times. It's a wonder that it still works after being ripped apart so much. But I don't think the pain of a system developer would be a very interesting topic, so let's talk about how we actually moved objects from level to level and have them stay there when they came back. The first issue is if you're having an item be part of a level, even if you moved it away from that level, when you hide and unload the original level, the item would hide and unload with that level. I guess you could solve it by having all the items be part of master, but our entire game is in master, so that would be a nightmare with both memory and management. After some digging, we found that the somewhat strangely named rename function for actors does exactly what we want. If you pass in a new level for it, then it removes the actor from the original level list, re-registers all the components, and adds it to the new levels list, which is exactly what we wanted. Because it re-registers the component, you're probably going to get some weird issues, like the physics resetting, begin play is happening again, and skeletal meshes going back to their T-pose state. In our case, that wasn't so much of an issue because the physics issues we could solve by just having the item swap level when you grab them and then they fly to the hand, so you don't really notice any weird physics shenanigans going on. And the begin play stuff, you could just save a variable and check if it's already had begin play once. After moving the items to the master level, when you're grabbing them, we needed to keep track of what level they're actually physically in. If you drop the item and it lands in a level that's later hidden or unloaded, we need to have the item hide with that level, otherwise it's just going to fall. Also, if you later unload that level and show it again, we need the items to actually recreate and stay there. Just before, so the first issue we solved by having the objects, having the levels, having the levels keep track of an array of the objects. Just before we hide the level, we move the items into the level that's hiding. That way, if the level is later turned visible, the items are still in memory, so they're just going to show again. And the issue of if you unload the level, we solved using our save system. So whenever an item comes to rest in a level, we add all of the relevant data to a added list. Things like unique ID, transform, what level it's in, if it has attached items, class, and whatever custom data we need. When the level is turned visible for the first time, after loading, we spawn all of the items in the added list. And if any items are in a similar removed list, items you've taken away from a level, we delete them. This system works pretty well with and gives permanence to items that you scatter across time. Bonus is that we can use the save transform to respawn items that fall off cliffs, or the player throws off cliffs, or we wanted to respawn for whatever reason. While a somewhat large negative is that state-based items like a clip of ammunition or something like that would need to be properly recreated with custom data, which when we prototyped the system was just an integer and never changed. Try recreating a 4-colored object with just one number, it's not fun. But all of this combined to create a system that successfully moved items between levels and saved where they were. So to summarize, making a VR game comes with a lot of unique challenges. Interactive hands, grabbing, swapping levels, and in our case, keeping track of everything that you move, just to name a few. But after solving all of these issues, we ended up making a game that a lot of people really enjoyed. So I hope this talk has given you some insights into ways to solve some of these challenges, or similar challenges, and if not, that it's at least been interesting. If all of this sounds interesting to you, then we're currently hiring, so check out our website or chat with any of us here at GDC. I'd like to thank Ben Markby, Huge Eastlake, Jack Mayer, Lance Shaney, and Nathaniel Sam for helping make this talk and generally being really supportive. And thank you all for coming to my talk. Yeah.
Who wants to go first?
Hello. You mentioned you made quite a few engine changes. So does the Unreal Engine, so Unreal Engine 4, I assume?
Yeah, U4.
So does it just not have a system for grabbing objects in VR, or is it just not very good?
I mean, you can grab objects and have them attached to the hand, but they're still related to whatever level that they're in, which is why we had to make our system to swap level, because all actors are relative to a specific level.
Mm-hmm.
So yeah, we had to move them away from that level.
Okay, thank you.
Hi, sorry, I'm not sure if you mentioned, but you said it was on PlayStation at least. Was there any other platforms that you released it on? Before I ask this question, otherwise it won't really make sense.
Oh yeah, the game is for PlayStation, Steam, Oculus, although not Quest, but...
Oh wow, okay. I guess my question was, did you run into any problems since it was cross-platform, that loading from either the levels from memory or anything like that, did they have different behaviors on any of the different...
Yeah, it took way longer on certain platforms to load, which was why we designed a system where you put the item into the watch and then it loads it in the background so the player can go around and do whatever they like, but when it's ready, it fades to white and moves the player. So that was how we got around that. God, what happened to the font?
Oh, hi. I noticed that you've got a real combination of sort of this blueprint system and then this more conventional kind of IDE. Did you have anything to say about sort of which tasks are better suited to being created in one of those versus the other?
Yeah. In general, just overarching systems, I feel like should be part of C++, while minor tasks like how the gun works and fires, it's fine to just make blueprints. But like our entire save system, that's very much belongs in C++.
That's awesome. Thank you.
Hey, with the persistent objects, did you have much, that sounds like a challenge between maybe accidentally losing objects from players. Did you have many challenges or workarounds for that?
Yeah, that was a problem that we worked a lot trying to solve, especially with time travel. Like in our game, you go to the first version of a level and time is all messed up and you need to fix it. If you just leave items there and then go to the new level, then all those items would just become inaccessible. We did a few things to try to mitigate all of that. So the items that you leave in a level that becomes inaccessible just go back to their original spot. And items that you throw off cliffs would just respawn. But in general, that's a system that we are looking at trying to make better. Because for the player, they might not realize where the item went.
Yes, please.
Yeah, I think we have just one more. Are you able to just like roughly ballpark how much time you spent all up building the posable hand tool?
That was when I was pretty new at the company, so probably a lot more time than was really needed, but
I mean, are you talking like 2 weeks? Are you talking 2 months?
more like 2 months.
Okay.
Especially like the first iteration of the tool was terrible. We saved everything into a JSON file, and then like at our vertical slice, the JSON file took half a second to load, so we realized that that wasn't good.
How many iterations did it go through, do you think?
Only 2,
Yeah.
thankfully. But the second one was very bare bones, and then one of our designers just kept saying, like, hey, make this a feature, make this a feature, make this a feature. So that helped a lot.
Thanks.
Yeah. If there's any other questions, feel free to just catch me on the at GDC, or if you just want to talk about game development, that's fun as well.